Okay, so today we're going to start with the electron dot diagram, which is also called AKA the Lewis dot diagrams. These are basically where you take the elements symbols and you write them down, and then you represent the valence electrons around them. You will notice on this periodic table there's hydrogen. It has one valence electron. In fact, everything in this column right here, column 1, has one valence electron. You notice how they're starting on the right hand side in the east, and you work around. And then we have column 2, everything has two valence electrons, so you represent it with 2. And then it's like east, west, north, and then south. And then you continue on with this. Okay, so to put the first 4, it's east, east, west, north, south. Then you go clockwise around for the remaining. Okay, but we're going to practice how to do that one. So first of all, you identify the number of valence electrons and you write it. So we're going to start with neon. And let me get this correct over here. Let's do it in blue. So first of all, what I'm going to do is write the symbol for neon, capital N and lowercase e. Okay? Now, when I notice this, it has, neon is in the last column, so therefore it has 8 valence electrons. So I'm going to identify east, west, north, and south. Okay? That's the first 4, east, west, north, south, and then the rest we're going to go counterclockwise around. 1, 2, 3, and then 4. Finish it up right there. So you should have 8 or 4 pairs, 8 electrons around. 2 in the north, 2 in the south, 2 in the east, 2 in the west. Okay? Alright, so now we're going to practice fluorine. The element is F. I'm going to start with that for you. Let's do it in green. Okay, so we're going to write fluorine. Write the symbol down. Okay, fluorine is in column 7. So again, we're going to start. I'm going to do a different color dot. Let's do red dots. Okay, so I'm going to do east, west, north, and then south. And because I have 7, I need 3 more. So now we're going to go counterclockwise, starting up at the top of the clock. 1, 2, and 3. Okay? So fluorine has 7 electrons. Remember, you do the 4, east, west, north, south, and then north, west, and south. All right, sodium. Let's go to sodium. Sodium's in A. And sodium only has 1 valence electron, so we're going to place it on the east. It's in column 1, so it only has 1. And carbon, symbol C, has 4 valence electrons. It's in column 4, 4A. So again, we're going to do east, west, north, and then south. Okay? All right, so now we have a practice worksheet, and we're going to practice that as a group in a minute. I'm going to go ahead and continue on with our notes. So let's go ahead and get the notes. Now, our elements that are on there, basically we have 3 different classifications on here. One of them is metals. Let's make this in blue. Okay, our metals are 1. And majority of the elements that are located are metals. Look at that. You can see in the green over here, majority of the elements on the periodic table are metals. Then we have another classification, things that are non-metal. They're the opposite of metals. And those in the orange are non-metals. But notice hydrogen is way over here in the metal group. And the only reason why it's there is for that 1 valence electron. Other than that, it has characteristics of nonmetals. And then we have these special things called metalloids. And metalloids are on the stair-step line. They're the purple ones there. And there's this heavy, distinct line that runs up and down, a diagonal like stair-step down. And that's on the periodic table. So they're the metalloids. All right, so let's talk about characteristics of metals. They are the biggest group, the most common. They are good conductors. Good conductors. They are solid, except for mercury. Mercury is the only liquid, or it's the only metal that is a liquid at room temperature. Then we have things that are ductile. That means I'm going to take metal and form it into wire. Luster, it shines, it reflects light. Malleable, we talked about malleable before, seeing the hammer down here. We're going to hammer it into a shape or into a sheet. Has a high melting point. And also the left side is where all the metals are located. Francium is the most reactive. Our most reactive metal and nonmetals both begin with F. But francium down there on the bottom of column 1A is the most reactive. It's going to react with everything. It's very explosive. And also metals have a high boiling point. Now nonmetals basically are dull. They're brittle. They're going to break easy. They're poor conductors. They're mainly gases. So the key thing to remember here is that nonmetals are a gas at room temperature. Low melting point, low boiling point. So therefore, sugar is a nonmetal compound. And if you put sugar in the oven, it's going to burn, char real quick. Whereas if you put salt has metallic properties. It will actually keep its consistency. Nonmetals are found on the right side. And look at this. Fluorine, the other F element, fluorine is the most reactive nonmetal. In fact, they're diagonal to each other. Then we have these special things, metalloids. They are on that stair-step line. They have characteristics of both metals and nonmetals, and they're found on the stair-step line. Okay, the metalloids that are found are boron, silicon, germanium, arsenic, tin, tellurium, polonium, and astatine. So all of these are considered metalloids. There is one that would be located right below boron, and it is on the stair-step line. It would be right here, and that is aluminum. But aluminum has so much metal properties, it is not considered a metalloid. But basically everything to either left or right of that line is considered a metalloid. Okay, there are some trends. So there are several trends, but we're going to focus on this one with how things react. So one of the things is as you go across the periodic table, and we read the periodic table like we read a book, left to right, the reactions become less and less as you move across from left to right. So they're more reactive on the left, less reactive on the right. Okay? All right, so now we're going to take turns and we're going to practice with writing the Lewis structure or the electron dot diagrams, and we're also going to focus on trends and just interpreting the periodic table today. All right, thank you very much.